In this video, we'll look at some key radian angle measures. So let's draw an initial ray in the 3 o'clock direction. And if our terminal ray sits right on top of that and we have no rotation, then we have a measure of 0 radians. Now, if we made one full rotation, so imagine sweeping out one full rotation, and we end up back at that 3 o'clock position, then we have a measure of 2 pi radians, because 2 pi radians span a full rotation, or there are 2 pi radians in a full rotation. So an angle with a measure of 0 radians and an angle with a measure of 2 pi radians, they look the same when drawn statically, but the 2 pi radians means we swept out one full rotation. So if we only swept out half of a full rotation, so if we swept out half of a full rotation, and 2 pi radians are in one full rotation, this means that we should have half as many of the 2 pi radians in that half of a rotation. So this angle that's half of a full rotation, that should have a measure of half of 2 pi, which is just pi radians. Now if we sweep out an angle that's half of those pi radians, so if we do half of that half of a rotation, we'll get an angle that looks something like this. It's a quarter of a full rotation, and the radian measure should be half of pi, which is pi divided by 2 radians. If we cut that in half again, we just look at half of that pi divided by 2 radians, that's going to be half of a quarter of a rotation, which is something like this, an eighth of a full rotation. And that's going to be half of pi divided by 2 radians, which is pi divided by 4 radians. Now we could also look at this one down here, another common one to look at. That's 3/4 of a full rotation. So the angle should measure 3/4 of the 2 pi radians, so 3/4 of the 2 pi radians, which is equal to 3 times pi divided by 2 radians.